All right, folks, it's Bass Action, back in action here. In this video, we're going to go through 4 conic application problems. The first 2 are going to be related to parabolas, and then the second 2 will be related to ellipses. One important thing to notice is that we have multiple forms for the equation of a parabola, so we are not restricted to the new form that we have. We're going to see that on our first example that we're going to do here, and we're actually going to do this problem exactly like we would have done in our Algebra 2 days. So let's read through this and talk through what we're looking for. We have a parabolic arch, so it says it's a bridge built in a parabolic arch, and you can see right here that our cars are going across the bridge. Here's our parabola, here's our river down below, okay? We want to read these carefully because sometimes it won't be a parabolic arch, it will be a semi-elliptical arch. It says that the maximum height of the bridge above the river is 40 feet. All right, so that means that we've got our nice vertex. It also tells us that it is going to be 25 feet high at a point 13 feet from the center of the river. Now, when we look at this problem, we have to choose where to put the XY axis. We can put the XY axis over here on either edge of this bridge, so right down here at this corner. We can put the XY axis here at the middle and put the X axis right on top of the bridge, or we can still put it in the middle but put the X axis down here at the river. Lots of choices. They're all going to get you to the same answer when we're done, but some work a little bit better for other people than others. I am going to work with the middle here, and I'm going to put my X axis down here on the river. And the reason why is that all of my numbers are in relation to or with respect to the river. So I want to put the x-axis there because it's going to be easier for me to work with those, less math that I have to do. It also means that we want to find the width of the river, and having the x-axis there is going to be a little easier for us. So now, it tells us that the maximum height of the bridge is 40 feet, which means the vertex placed based on where we put origin is the point 0, 40. It tells us that our point, the other point that we have right here, is 25 feet high, 13 feet from the center. So we're going to go over 13 and up 25. If we want to find the width of the river, we're going to find our x-intercepts here. We really just need one of these x-intercepts. Once we know one, then we can double it. This problem, like I said, is really straight from Algebra 2. So when we write our equation, we're going to start with that form. We're going to say y minus k, and we're going to say a, and x minus h squared. Filling in our vertex, we're going to say y minus 40. We don't know that leading coefficient. The h value is going to be 0, so I can just write x squared with or without the parentheses. Now I'm going to fill in this nice xy pair I have here. So I'm going to say 25 minus 40 is a, and I'm just going to go ahead and jump straight to that 169, which is my 13 squared, which means my a value is a negative 15 over 169. So my equation is y minus 40, fill in my a value, and then x squared. If I'm wanting to find my x-intercepts, that means that the y value is 0. So this becomes a negative 40, negative 15 over 169, x squared. Now, I've got negatives on each side, so those would cancel. So I'm going to isolate my x squared. So I end up with x squared. I'm multiplying both sides by this reciprocal. So I have 40 over 1 times 169 over 15. Now, this is really down to just a calculator problem. I'm going to take the square root of each side. That's going to give me an x-intercept of approximately 21.2. So the width of the river is going to be approximately 42.5, depending where we rounded that. So if you double the 21.2, you'll have 42.4. If you take the running decimal, you'll get 42.5. Okay, on the next problem that we want to look at, we're going to actually use our new form. This problem is going to work with the searchlight. Now, when we think about the searchlight, think a satellite dish, although it's going to be very big. Okay, it's going to be a paraboloid of revolution. Okay, so this paraboloid of revolution that creates the searchlight takes just a parabola and rotates it. You can certainly Google what they look like, but again, just picture a satellite dish. Now, what it's going to tell us is that we have this light source and it's located 3 feet from the focus. As soon as you see the word focus, okay, as soon as we see that focus, we know we're going to want to use our new form of our parabola. It also tells us that the opening is 30 feet. So let's give ourselves a drawing of a parabola, just any rough picture of a parabola. We're going to fill in our XY axis, and this parabola is going to represent a cross section of our satellite dish. If you can put that vertex right there at 0, 0, that's going to make things easier for us. Since we need our focus, we can give ourselves a point for our focus, and it tells us that that's going to be 3 feet from the vertex. It did tell us that the width of our dish is, the opening is 30 feet. So this whole thing is 30 feet. So this point over here has to be over half of this number. So I can fill in this point is 15, and I don't know its y value. However, this y value will represent the depth of our satellite dish. So let's write our equation. We're going to have our x minus 0 because the x coordinate of the vertex was 0, and that's going to be squared because it's up, down. I know that this 3 is going to be my p value, so this is going to become 12, because remember this is 4p. That's what that 12 came from. And then y minus 0. So in a much simpler form, this really is just x squared 12y. So now, if we want to find the depth, if we're solving for this y, we just take our 15 and substitute that in here. So we're going to have our 15 squared is our 12y. So y is going to equal our 225 divided by 12, or y is approximately 18.75 feet. And of course, it'll always tell you how you're going to need to round those, so it depends on whatever instructions might be in the problem. Now, we're going to flip gears, and we are going to look at 2 problems related to ellipses. And you'll notice on this first one, I have given you a picture of this racetrack. I've drawn in this ellipse. So we have a racetrack here, and it's in the shape of an ellipse, and it gives us a whole bunch of information about it. It's going to tell us that the racetrack is 80 feet long. It's 50 feet wide. And then we want to find the total width. So we're going to ultimately be looking for the total width 10 feet from the vertex. So in this picture, what we need to find in the very end is this whole segment right here. Now, what we want to start with is labeling our picture. So that 80 feet long, that means this whole thing is 80. And let's draw in, again, an XY axis, because it does make this easier to think through. Notice that I'm putting origin right at the center of my ellipse. So I'm going to go ahead, I'm going to fill in my 40 here. That means this side is also 40, but this little gap right here is supposed to be 10. So I'm going to only fill in a 30 right here. It says that it's 50 feet wide, so this total width here is 50, so I'm going to fill in my 25 and 25. And I'm ultimately trying to work with this point right here. That means that I will have gone over 30 and up, I don't know how much. This is very similar to that bridge problem. So we're going to say 30, comma y. Now, let's write the equation. Since our center is at origin, we can say x squared plus y squared equals 1. My horizontal distance is 40, so I can square that and actually even fill in 1600. This vertical distance here is 25. I can immediately square that and fill in 625. Working with my xy pair now, I need to solve for y. I'm going to take my 30 and substitute it in. So I'll end up with 900 over 1600 plus y squared over 625 equals 1. Reducing my fractions, of course, my zeros cancel. And now I'm trying to solve for y. Now, a lot of students lose this 1. They think of this as a 0, but it's not 0. We're going to have y squared over 625, and we're going to have 1 minus 9 over 16. That means this becomes 16 over 16. So we have y squared over 625 equals 7 over 16. Y squared is going to be 7 times 625 all over 16. And now I can take my square root of each side. And I'm actually going to write the rest of this up here. So that means that our y, when we solve for this, our y is approximately 16.5, but we need the width of the racetrack, so we're going to double our final answer. So our final answer on this problem is going to be 33 feet. Don't forget to double it because we want the total width of the racetrack. The last one that we're going to look at is a whispering gallery. Whispering galleries are a common application of ellipses. Okay, it is a semi-ellipsoid. Let's look at the pieces that we're given. We're given that Jim is standing on one focus, and he is 3 feet from the wall. That's very important. His friend is going to be on the other focus and is 90 feet away from him. So let's get a picture of this. Let's draw our ellipse. Again, we're going to think about a cross section here. We can think about filling in this XY axis. Okay. Jim is going to be on one of the foci, and he says that he is 3 feet from the wall. So that means that the other focus is 3 feet from the other wall. If his friend is 90 feet away from him, then each of these pieces has to be 45. So now we know that the distance from the center to one of the vertexes, remember that would be where the wall is going to be 48. It asks how wide is the gallery? We just need to double this and we'll get 96 feet. And if we want to know how high the ceiling is, we don't actually even need the equation for this ellipse. We can simply use our c squared, a squared minus b squared. C is the distance from the center to the focus, that's 45. A is going to be the center to the vertex, in this case the edge of the wall, so 48 squared minus b squared. So our b squared is going to be 48 squared minus 45 squared. Oops, there we go. So our b is approximately 16.7 feet. And all our whispering galleries are going to work that exact same way. So we'll do more practice with this in class, and if you've got any questions, jot those down and just be ready to ask them in class.